AP Calculus BC, Unit 6, Day 10, Review, Pretest, Part 2 for your upcoming test. So Part 2 is going to have a bunch of differential equations like this. And that's been sort of the common thing, tying everything in this unit together. Remember that you have to state the domain of the solution. So I am helping you out by putting it in the answer column. You got to put the domain, okay? All right, so this is pretty much Calc AB, unless some of the new integration techniques come into play, which is possible. Okay, so we have to separate the variables, integrate both sides, e to the y equals x cubed over 3, plus c, use initial condition. So c equals e cubed. Plug it back in, e to the y equals x cubed over 3 plus e cubed. We're going to take the natural log of both sides. And can't distribute natural logs, so this is all stuck together. Let's see, just make sure I did this correct. Yeah, okay. My solutions, I wrote something different. So, okay, let's keep going. So, domain, this, e to the y should not be allowed to equal 0, which is just impossible. So, we're good there. The inside of a natural log has to be positive, right? So I think the easiest thing to do, we don't have to worry about the inequality and stuff like that because it'll be easy to identify the domain, is just think of it as like equal to 0. It can't be equal to 0. X cubed equals negative 3e cubed. We take cube root of both sides. So x equals negative e cube root of 3. On a line, we put an open dot there. And 3, well, cube root of 3 is like, it's definitely bigger than 1 times e. This is definitely like some negative number. So our positive 3 is for sure on the right, for sure. Single open interval. So for the domain, it's going to be negative e cube root of 3 comma positive infinity. It's a little different than what I had on my solutions. So I made a mistake. All right. Okay, number 2, separate the variables. Pretty easy to do this time. Integrate both sides. Y equals to natural log the absolute value of x plus c. Plug in the initial condition. Natural log of positive 1 is 0. C equals 0. Y equals 2. Natural log the absolute value of x. Now, any solution to any of these that involves absolute value, I for sure guarantee we can rewrite without the absolute value by the time we're done. Once we figure out the domain, it's going to always be positive or always negative, because this right here, x can't be 0. But it could be negative or positive, but it's going to get narrowed down to one or the other, because there's a corner here and we have to split it up when the derivative is undefined. Single open interval. So put 0 on there, pretty easy. Plug the negative, put the negative 1 there, initial condition there. Okay, that's your domain. So the fact that all these are always be negative, always going to be negative for sure, means that we can write this answer a little better. We could just put a negative on the x and drop the absolute values. So that's your answer. You could bring the 2 in and write it as natural log of x squared. That works too. All right, either way. Okay. Next one, separate the variables. Y squared dy equals dx. Integrate both sides. Y cubed over 3 equals x plus c. And plug 3 in. So that's going to be 9. So if c equals 10, so we're going to rewrite it. Y cubed over 3 equals x plus 10. I'm going to multiply both sides by 3. Y cubed equals 3x plus 30. I'm going to take the cube root of both sides. No plus or minus. It's an odd root. There's no restrictions here. Okay, so domain of this is all reals. Domain of our answer on its own is all reals, but you have to check the derivative. And the derivative says derivative is undefined and y equals 0. So y cannot equal 0. Well, let's figure out when y equals 0. Let's take our new answer for y. We got to find the x's. So we can cube both sides. Divide by 3. So x cannot equal negative 10. So put this on number line, open dot. Our initial condition is at negative 1. So this is our domain. So the answer is y equals the cube root of 3x plus 30 for the domain negative 10 to positive infinity. This negative 1, don't break it up. That's not one of your boundaries. That's just helping identify where your domain is. Okay. Keep it going. Separate the variables. I'm going to rewrite this as y plus 2 to the negative 3 halves because it's a power rule, and I just feel like that makes it easier. So this is going to be y plus 1 to the negative 1 half divided by the new exponent equals x plus c. I'm going to rewrite this as negative 2 over the square root of y plus 2 equals x plus c. Plug in the initial condition, plug in negative 1 for y, 0 in for x. That's going to be square root of positive 1 is 1, so c equals negative 2. So we're going to rewrite our answer. I'm going to flip both sides. And multiply both sides by negative 2. And square both sides. And subtract 2. So this is going to be positive 4 over x minus 2 squared. I mean, I personally like that a little better, but that's up to you. So that's our answer. Now we got to figure the domain. So there's domain issue here. X cannot equal 2. There's also a domain issue up here because this is a square root. So y plus 2 has to be greater than or equal to 0. So y, we could just say, has to be greater than or equal to 2. Now, to figure that out, I mean, this is easy, but to figure where that happens, we take our answer for y and say make it greater than 2. So we add 2 to both sides. Then 4 over x minus 2 squared has to be greater than or equal to 4. Flip both sides over. And at this point, I'm just going to say not equal to, because it's got to be open dot. Multiply both sides by 4. Take the square root of both sides. Add 2. So we get x equals 3 and x equals 1 are other values that are not allowed. Right? I'm just trying to make sure this makes sense. Okay. I don't know. Now I'm a little thrown off here. Let me double check my work. Shoot. -2. Y is greater than or equal to -2. -2, which makes this a 0. Which means this has to be greater than or equal to 0. Well, this is always going to be positive. So the main issue here is that x cannot equal 2. Same thing we cut up here. All this makes sense here. So quick little line. Put 2 on there. Initial condition is 0. All right, so final answer. Y equals 4 over x minus 2 squared minus 2 for the domain. Negative infinity to 2. That's it. That's the answer. Okay, I made a little mistake earlier there. Okay, a few more of these. Okay, separate the variables. Ooh, you know what I think this is an opportunity for? Integration by parts. Lip it. Integration by parts. We got poly, expo. Ooh, cool. Shortcut, right? Poly expo or poly trig. You use shortcut on. I will take advantage of that. So the one that if you take a derivative eventually gives you 0 is definitely the one that you want to take a derivative. The other one you're going to integrate. So this is going to be negative e to the negative x. This is going to be e to the negative x. And this is going to be negative e to the negative x. And the first one's plus, the next one's minus, the next one's plus. It keeps alternating. And then we multiply through by a diagonal. Okay, so we get y squared over 2 equals negative x squared over e to the x. I'm just changing it back to a positive exponent. Minus 2x over e to the x minus 2 over e to the x plus c. Good times. All right, now we're going to plug in the initial condition, -2 in for y. And this is going to be 0 squared over e to the 0, which is 1, but 0 divided by anything is 0, minus 2 times 0 over e to the 0, which is 1, but that's going to be 0, minus 2 over e to the 0. Ooh, that's not 0. That's going to be -2. So we get positive 2 equals -2 plus c. So c equals 4. Be careful. That's not 0. The ones with zeros on top, those are 0. E to 0 is 1. So we're going to rewrite it. Y squared over 2 equals negative x squared over e to the x minus 2x over e to the x minus 2 over e to the x plus 4. Multiply both sides by 2. Now, I'm tempted to put these all into like a fraction or something. I don't know. You got to take the square root of both sides, plus or minus. I don't know. Let's see. Negative x squared minus 2x minus 2 plus, 2, 4, because you got to multiply them by 2, plus 8 e to the x, all over e to the x. Now, this can't be 0. That's fine. But the inside of this has to be greater than or equal to 0. That's an issue. Up here, y cannot be 0. Which, by the way, is going to be the same thing as what makes this inside equal 0. So we're doing the same thing in both places. So it's really the numerator. Okay, so we have negative 2x squared minus 4x minus 4 plus 8 e to the x cannot equal 0. I mean, we could factor a -2 out. But we're not going to solve this by hand. But on a graphing calculator, if we were allowed to use it, I'd put this in x squared plus 2x plus 2 minus 4e to the x window. I don't know. I mean, try negative 10 to 10, negative 1 to 1. I just want to see the x-intercepts of this graph. There's one right there. So let's find it. Second calc, 0. It looks like between negative 2 and negative 1. Guess negative 1.2. There it is. So x cannot equal negative 1.300075. So our number line is going to be open dot there. And our initial condition is 0, so that's over here. So that's your domain. Now, we got to decide if it's positive or negative, by the way, period. It's actually negative because you need to get negative 2 when you plug in x equals 0. So that's actually negative. So our answer, the final answer is y equals negative square root of negative 2x squared minus 4x minus 4 plus 8e to the x all over e to the x for the domain negative 1.300 to positive infinity. On your test, I think you'll be able to solve them all without a calculator. Okay, let's see this one. Separate the variables. Which is actually pretty easy to do. They're pretty much already separate. Integrate both sides. Now this is going to be inverse, it looks like inverse tangent, but we need to make this a 1. So we got to factor a 4 out. And we can bring the 2 out in front too. And it's going to be x squared over 4 minus 1. This is going to be your u, x over 2. So u equals x over 2, du equals 1/2 dx. I don't want the 1/2. I'll multiply both sides by 2. So we got a little u substitution here. Actually, you know what? It's supposed to be plus, isn't it? X squared plus 1 is inverse tangent. Dang it. Okay, no good. What we do have to do here is if we factor the bottom, we have to use integration by parts. All right, let's do it. A over x plus 2 plus b over x minus 2. Right? And we multiply through by the least common denominator. 2 equals a x minus 2 plus b x plus 2. Plug a negative 2 in. A equals 2 divided by negative 4. It's negative 1/2. Plug a positive 2 in. 4b equals 2. B equals 1/2. All right. So, okay. This is going to be negative 1/2. 1 over x plus 2 plus 1/2. 1 over x minus 2 dx. And over here on the left, you just have y dy. So you have y equals negative 1/2 natural log of the absolute value of x plus 2 plus 1/2 natural log of the absolute value of x minus 2 plus c. I'm going to clean these up right now. This is going to be 1/2 natural log of the absolute value of x minus 2 divided by x plus 2, because this one has a negative, plus c. Use initial condition, 0 for y. If we plug a 3 in for x, we get 1 over 5. So c equals negative 1/2 natural log of 1/5. Or you could bring the negative inside and be 1/2 natural log of 5. Or you can bring the 1/2 in and be the square root of 5. I mean, whatever. So y equals 1/2 natural log of x minus 2 over x plus 2 plus 1/2 natural log of 5. I mean, we could bring this natural log of 5 inside. Why not? They both have 1/2 front, natural logs. So y equals 1/2 natural log of 5x minus 10 over x plus 2. All right. But I've also said that we should always be able to write this without the absolute values for our final answer based off the domain. I think we'd also bring this 1/2 in as a square root. But let's check out the domain. 1, x cannot equal -2. The other thing is that 5x minus 10 over x plus 2 has to be greater than 0. If we go up to the top, this shows us that x squared minus 4 cannot equal 0, so that means x squared cannot equal 4, which means x cannot equal plus or minus 2. So we have two issues there. This right here, this is a good one for a line check. 5 times x minus 2, -2, +2. I mean, we could test it. X equals 3, positive, negative, positive. That's where that's true. But I'm just going to do one line with -2 on it and +2 on it. Our initial condition is 3, so it has to be over here. Which, by the way, does at least match the regular domain of it. But that was unnecessary. We could just do this one line check. So we know we're going to be plugging things in that are bigger than 2. So that's going to be positive. The inside is always going to be positive. So our final answer, y equals natural log of the square root, drop the absolute values, because it's going to be positive for sure, for the domain to the positive infinity. There you go. All right, last one. This might look familiar to you. I mean, if I rewrite it a little bit, factor out a 2y, I get 10 minus y, ky m minus y. This is totally logistic. Okay, but on this part of the test, you can't do logistic. I mean, I'll show you what the answer is with logistic, but if you do it that way perfectly, I'll pretty much only give you half credit. If you make any mistake with it using the shortcut, you'll get no credit. So you're going to probably want to do it the long way. I'll do the short way real quick. So obviously k equals 2, m equals 10. The equation is y equals m over 1 plus a e to the negative nkt. So far we have 10 over 1 plus a e to the negative 10 times k times t. We just got to find the a value. So that's where initial condition comes in. It gives you 10 over 1 plus a. So 2 plus 2a equals 10. 2a equals 8. A equals 4. So your answer is y equals 10 over 1 plus 4 e to the negative 20t. Domain, there's no domain issues up here. The bottom can't be equal to 0, but it's never going to be equal to 0 because you have a positive raised to any exponent is going to be positive. Times 4 is positive, plus 1 is positive. This is never 0. So the domain is negative infinity to positive infinity. So sure, you could do it like this, but you're getting half credit if you pull it off perfectly. But I expect you, on part 1, I let you do some problems where you just memorize this. But on this part, I want to see you actually be able to pull it off. So starting back at the beginning, let's do it as solving a differential equation. So you need to separate the variables. You're going to want to factor -2y out. It's going to be y minus 10. I'm going to bring the -2 back over to the other side. You guys are cool with that. Multiply both sides by -2. So now we're going to integrate both sides. This is partial fractions. It's going to be a over y plus b over y minus 10. So we're going to multiply through by the least common denominator. You plug 0 in. A equals negative 1/10. Plug 10 in. B equals positive 1/10. All right, let's see. Now I'm doing this one a little different than the way I did it in my solutions, but we should get the same answer. I put I didn't factor a negative out, but we should get the same answer when we're done. Okay, so we're gonna get negative 1/10, 1 over y plus 1/10, 1 over y minus 10 dy equals the integral of negative 2x dx. So this is going to be negative 1/10 natural log the absolute value of y plus 1/10 natural log the absolute value of y minus 10 equals negative 2x plus c. Let's combine these together. 1/10 natural log y minus 10 over y. I'm going to multiply everything by 10 right now. I really rather not have extra fractions. And I'm just going to write plus c here. Now I'm going to find the c value right now with the initial condition. So if we plug in 2 for y and 0 for x, you get c equals natural log of 8 of 4. Okay, so now we're going to rewrite it. Natural log the absolute value of y minus 10 over y equals negative 20x plus natural log of 4. Exponentiate both sides. We're going to get rid of the absolute values by doing plus or minus. This, we can break this apart with the 4 in front. Rules of exponents. We should decide if it's positive or negative right now. Okay, so if we plug 0 in, we get positive 2. So 0 here, this is going to be 4. 2 here is going to be negative 8 over 2 is negative 4. We want the negative, right? We actually want the negative. So now we're going to multiply y to the other side. Bring the y back, or bring this y over there. Either way. And divide both sides by that. So y equals 10 over 1 minus 4 e to the negative 20x. I feel like I made a mistake. Like this should be positive. So where did that mistake happen? If we plug in 0, we should get positive 2. Why did I think? So we want positive 2, 2, 2, negative 8. Or that's gonna be negative. That should be negative. Is my c value correct? I think so. I don't know what's going on. I feel like something's wrong. Well, in this case, at this point, if you made some mistake, you're still going to get way more points than the other one that you did perfectly. If you did the other one perfectly, you still got to do domain. Now, if this is my answer, I think it's going to have a domain issue. I really think it's supposed to be plus. So, just looking at my work again closely. Make sure I didn't make any mistakes. I don't know. Oh, here's my mistake. This is supposed to be negative. I just dropped it. So then when you move to the other side, it's positive. Gosh, little tiny mistake. Now this isn't going to have any issues because the bottom is never going to equal 0 because e to any power is positive times 4 is positive plus 1 is positive. This is always positive no matter what. So for the domain, I mean, you could negative 3 positive 3. I mean, you could show some work if you feel uncomfortable about it. See if you can make this equal to 0. Take the natural log of both sides. Well, what's the natural log of negative 1/4? Impossible, undefined, can't happen. Just there is no solution. There's no way to make that denominator go. Anyways, on your test, I'm expecting the long way. The long way is for full credit. The shortcut is for half credit if you do it perfectly. If you make any mistake, it's 0 credit. And by the way, if you apply this to a problem that you think is logistic and then turns out to not be logistic, well, then you get 0 points no matter what, for sure. So you can only apply the shortcut if it's for sure logistic. And I might give you something that looks really close to logistic but isn't. But if you do it perfectly on only the appropriate problems, you'll get half credit at most. Make any mistake, get 0. Do it this way, I'm just going to take off points for whatever mistakes you make along the way. But I think there's a higher likelihood you'll get a higher score on this. That's it. Be ready for the test. A bunch of differential equations on part 2.